Hey guys, I'm going to walk you through the solubility practice that we gave you. You should have submitted your stuff on GradeCam, but I thought it might be helpful for you to actually kind of see the process as well. So first thing I'm going to do to answer 1, 2, and 3, start by finding the solubility curve for that specified substance on your graph. So we find it here. Okay, go to the temperature. And for us, it's going to be 70, so we follow that line all the way up until it falls directly on the solubility curve. Okay, and then go over to the y-axis to see the grams. And for this first question, it's going to be 130 grams per 100 grams of water. So you repeat that process for question 2 as well as question 3. So now if you notice, I went ahead and found on my graph both number 2 and number 3 so that you guys can see how I came up with those numbers. So now moving on to questions 4, 5, and 6. These are asking you which one's most or which one is least soluble. So the key to this on number 4 and 5, right, these are asking you for most soluble at a specific temperature. Okay, so all you have to do is go to your graph, right? So we'll do number 4. Go to temperature, and it says at 15, which is about here. Okay, and most soluble means you are looking for the highest line at that given temperature. So if I just want to go ahead and take this line all the way up, okay, it looks like Ki has the highest line, so that's going to be your answer there. On number 5, do the same thing, right? Go to 40 all the way up, and our option is sodium nitrate, right? Since Ki is going and off the graph and we can't see it, NaNO3 is going to be our best option there. On number 6, now we're looking for the least soluble at our given temperature. So now we do the opposite. We don't want to look for the highest line, we want to look for the lowest line. So if we go up, the first line we hit is for KClO3. So that's going to be our answer there. And now we're going to go ahead and move on down to 7 and 8. So on number 7, you actually don't need the solubility curve at all. Okay, the key to answering this question is, do you know and can you define the words dissolve versus dissociate? So I went ahead and provided the definitions. You guys should see them now. To dissociate, that's specific to something ionic. Dissolve is for molecular. So in the substance we're being asked about, sodium nitrate, okay, biggest thing, sodium, right, is a metal. Okay, and remember with our ionic compounds, you have to have the metal with the non-metal. So that right there leads me to say that sodium nitrate is ionic and therefore will dissociate when placed in water. So moving on to number 8, you are going to have to use the solubility curve as well as the numbers that you got up here, right? So 100 grams of sodium nitrate at 80 degrees Celsius. So before we can answer this question, you really need to make sure that you understand how to identify unsaturated, saturated, and supersaturated when answering this question. So you should have these vocabulary terms on the notes document, so I would suggest you go back to that and review. Right, so once you have your chance to review, I went ahead and gave you guys what you're going to be looking for. So unsaturated, right, the point that will fall under the line, okay, and if it's saturated, it's going to be directly on the line, and then supersaturated means that point is going to be above that solubility curve. So going up to our graph here, right, keeping in mind the points, so 80 degrees is our temperature, so we're here, okay, with 100 grams of our sodium nitrate. So here's the line for sodium nitrate, right? So here is our 100, so go ahead, take that line up and you want to find the point on your graph. So if you notice, right, here's the solubility curve for the sodium nitrate, and our point is actually under that solubility curve. Okay, so that means that based on the information given to us, this would be classified as an unsaturated solution. All right, so for number 9, we're going to repeat the same process that we did in number 8. Okay, but this time we have ammonium chloride, okay, and we've got 50 grams at 50 degrees Celsius. So go ahead, we'll go to our graph. So here's my 50 grams, 50 degrees Celsius. Go ahead and let's follow those lines. Right, so the substance that we were looking for, right, was ammonium chloride. And it turns out our point falls directly onto the solubility curve for that substance. So if we go back down here, right, then that's going to tell me that this is a saturated solution. So on number 10, we're going to have to do a little bit of math with this. So as you read through it, if you have an unsaturated solution, okay, so remember that means that the amount that I have does not fall onto that solubility curve, so I have the potential to add more to my solution. Okay, so we have 40 grams of, again, ammonium chloride and 100 grams of water. Right? How many more grams of ammonium chloride can be added to create a saturated solution? So on yours, it should also say that all of this is at a temperature of 50 degrees Celsius. So the next part of this question is really important, right? How many more grams of ammonium chloride can be added in order to create a saturated solution? So remember, saturated solution means that the point is on the line, right? So as we saw in question 8 and 9. Right, so let's go up to our graph and see, right, at this given temperature, 50 degrees Celsius, how would I make a saturated solution? So how much mass am I going to need of my ammonium chloride? So right now we have 40 grams, right? So we're here at 50 degrees Celsius. So if we follow that point, right, we can tell that we are actually below the solubility curve for our ammonium chloride. Okay, so in order to have that saturated solution, we need to have a point that falls on that line. Okay, so again, at 50 degrees Celsius, right, we go all the way up, and in order to have a saturated solution, okay, that requires 50 grams. So that means you find the difference, right? We need 50 grams in order to be saturated. We have 40 grams, so we need to add 10 more grams, right? We're answering this question to have a saturated solution.